8, number 2 on the worksheet.
Like some questions because I have one on 10.
Sure, I can do 10.
The trig identity
On 2?
test.
9.
Oh, 9.
Yeah.
So we have 9, 10, and 12.
I mean, the number 9, it's pretty obvious which one you should pick.
You
Pick
think?
the two.
Obviously the 2.
You gotta pick the 2.
I thought the 2 would be easy to break
And then you
apart.
multiply it by all of the
We
things.
good?
Yeah.
Okay. Okay. So, number 9, 10, 12. How's that?
Yep.
Sounds like a roll? Okay, good. Number 9. So, as you guys joke, I get what you're
You
saying.
start with the 2.
You start with the 2.
You try it. And you
That's
finish.
the
I mean, because
intent.
it would be the more difficult side to do.
Right. Okay.
Okay, the first thing I noticed is that they're integrals. That's minus. That means they would, when you
Conjugate
would
to,
factor
well,
them,
you don't
they would
do it with each.
They don't deal with each other, so we're not going to worry about the
Okay, yeah.
conjugate. Yes.
Do you foil
Oh, you do.
both of them and then self cancels out when you're
You
done?
do.
And then you
That
just get 2.
sounds lovely.
Isn't it nice?
It's not bad.
It's really not that bad. Once you kind of start foiling, you're like, oh, that makes
I'm
sense.
gonna go out and limit
So let's
say
look.
It's gonna end up with 2 sine squared and 2 cosine squared.
So you kind of get the idea.
Mhm.
Okay, so how does this happen? I'm sorry, I won't do it. I'll do it slowly. So this means this. You guys with me?
Yeah.
Okay. So you know when you multiply, what's a mistake that somebody could make when they're doing that squared thing? Just kind of bring the 2 in by mistake and not FOIL, right? Yeah,
Oh, yeah, that's what I did.
that's what you did.
But just distribute the.
There we go. You handled my mistake. My favorite no is what you did. That's good. We're working on that. My favorite no. So we're going to multiply first, outer, inner, last thing. Yeah.
Mm-hmm.
So we have sine squared, and then we have 2 sine cosines,
Mhm.
right?
Right.
So this times this is sine cosine. This times this is sine cosine. So there's 2 of them. And then this times this.
Cosine squared.
Beautiful. So far, we've only taken the first thing and foiled it. What do we have to do with the second thing?
Foil it.
As
Foil.
well, right? What's the only difference? There's a minus in between.
Yep.
So if I just put it here so I don't have to rewrite them on the board, there's a minus in between. Same concept.
Mhm.
So it's sine times sine, so plus sine squared. And then negative sine cosine minus sine cosine. So minus 2 of them?
Yeah.
So minus 2 sine cosines. And then plus,
Cosine squared.
good job. Are we feeling it?
Yeah.
And now we just start eliminating. So this guy
Middle ones.
goes away with that guy
Combine like terms.
and combine like terms. So we have sine squared. Here's what I think. I see sine squared plus cosine squared. What's that?
1.
1
One.
whole, right? So this plus this is 1. So they're really not like terms. I'm using the Pythagorean identity. Yes.
But how do you know like when to do that and when not to? Because I guess like there's some situations where like you're kind of questioning whether you should convert it or not.
I always see sine squared plus cosine squared to become 1 and the easiest way to work it. Because you're breaking it down into something really
Because the answer doesn't have sines and cosines in it, it only has
True.
numbers in it, so you want to get everything to hold.
Right, in this case, it's kind of obvious that you don't want the word sine and cosine in it.
So even if you convert it more than you need to, you're still going to get to the right answer. You just
Yeah.
might have some extra work.
Yes.
The backtrack.
Yeah, you have to cut.
And then, yeah, a little bit. You don't want to have to do too much work, right?
There we go.
So there's
That's
your,
the hardest problem.
yeah, right.
1 plus 1.
Is everybody cool with how that happened?
Hey, like, we should just, like, show that.
Just zoom in
take-
on that.
yeah,
What
just
did you
take
do
the
in
one-
math today?
one
Just
plus
We're in
one.
math today, because that's what we do. We do the hard stuff.
Yeah, just leave the 1 plus 1 equals 2 for third period.
Right.
They might need
Third period's the same kind of group that you guys are.
No,
So
but they'll still be like,
What?
what is
are we gonna
second
do
period
here? Oh,
doing?
1 plus 1.
second period had a hard time. We got to the last step. I used to have a student, I would do math, Algebra 2, one of my first years here, and I would teach really pretty intense because he seriously could do all that hard stuff and then totally lost it on the 1 plus 1.
So mean.
It's truly me too.
I like how you can do all this hard stuff, but when you're adding or
I
subtracting,
get a little
numbers,
nervous. Get a little
Yeah.
nervous.
The calculator 1 + 1 is.
Oh, yeah, it's 2. That's right, good.
Miss K?
Wait, what's
So,
this?
will there be a test like where you have problems like this?
I'm going to give you a review sheet for it today.
Okay.
Okay.
All by identities.
Because our test is Monday. So I'm going to give the review sheet out today. We'll work on it for the next couple days. Make sure we understand it for Monday. How many people aren't going to be here Monday?
See, I'm really afraid of missing the eclipse because my bus is always late.
Oh.
So.
Well, the eclipse is throughout the day.
The eclipse is like 1 to
2.
Yeah.
I've been told in my science classes that we're gonna go out and look at it, but
Left.
Well, I think so.
I was gonna say the one with John.
You could do the right, but I think
The one
left.
with what?
John on it. He's not responsible.
He's not.
It's hard to insult him.
I can't, he's not even
Follow
here.
me in here to roast. Hey, John walks up from his class.
He's
One-
grown
one
up.
building.
He doesn't want to hang out with me anymore.
Isn't he in next period?
Yeah, he just doesn't want to hang out with me anymore.
show him this
He's afraid of
video.
us.
Roast him now.
Yeah, roast him now and then we'll show him the video.
Do it while I can. Too cute. All right, sine over cosine plus cosine over sine. Are we cool?
Yep.
Now what?
Foil.
I think so.
Yeah.
Why not? Yeah, that's cute. So this times this would be what? Sine,
Sine squared.
over cosine. Is everybody good?
Uh-huh.
And then
The signs cancel out. For the next one.
where?
Where
The
you,
next one?
where you distribute sine theta to cosine theta over sine theta?
Right.
The outside?
Oh, yes.
Yeah.
So we did first and then the outside. So, okay, I'm with you. I'm with you now.
What's
So-
cosine? What's sine?
I'm just going to actually show my work. Are you guys surprised?
No.
Yeah.
Yeah.
I know, I am too. It's not going to last. And then the next one's going to be
Cosine, sine, over sine.
Sine over
Cosine.
cosine. And then finally, last but not least,
Cosine.
over sine. Right? So far, so good? So,
Thank
So it's sino and cosine.
Cosine,
Oh.
sino.
with my stuff,
Yeah.
Sorry.
That's why I just leave out the thetas until the
I
end.
know it's a
Like,
thing, but it just looks funny.
let it go, let it go. Okay, so sines cancel, you said, cosines cancel.
Yep. So we have sine squared over cosine plus cosine plus sine plus cosine squared over sine.
Never heard more of a confusing statement.
Okay, that was a lot of talking.
Not a lot I understand.
That I did not.
It makes sense.
She just wrote down
Okay,
what
that's
I
what I have
said.
written.
There,
She wrote down what I said.
yes.
Would you want to convert both sine squared theta and cosine squared theta into their Pythagorean equivalent?
Yes, you could do it that way.
Both of them?
Or you could get a common denominator that matches with one of these.
Yeah.
So for example, if I wanted to put a cosine down here, I would multiply the top by cosine, which would leave me what on top? Cosine squared, right? So I'd have cosine squared over cosine.
Mhm.
So sine squared plus cosine squared is 1.
Mhm.
1 over cosine is secant.
Oh,
My answer.
okay.
That's one way.
Oh.
Yeah. Uh-huh. Or, but your way would be perfect too, because this would be 1 minus cosine squared,
Mm-hmm.
right? Plus cosine, and then you have to do a little magic with it. It might take a few more steps.
See, yeah, you'd have to get a. Yeah.
Yeah. You with me? Yeah.
But then wouldn't you have to multiply by sine as well because you've got sine in the.
No,
Did I be-
you'd have 1 minus cosine squared
Mm-hmm.
over cosine. You get your common denominator of cosine squared over cosine, and the minus cosine squared and the minus cosine squared would cancel. You'd be left with 1 over cosine, which is secant.
And then what about the sine theta over 1 plus cosine
Same
squared theta over.
concept. You would do 1 minus sine squared, and you would get a common denominator for that.
But you can separate those two from each other?
Yes. Yeah. Okay, so is everybody cool? Do you guys do it without me or not?
I
So
do.
we have sine squared over cosine plus,
Cosine squared over.
right, so is everybody good with that? And I think what Nick's question was, can we do that, just you work with the two?
Because
Absolutely.
you're, in the end, you're adding them together.
Yeah. And then over here, we have sine squared over sine plus cosine squared over sine. Everybody good?
And
So,
then have
together, those make 1
one over cosine,
over cosine.
Which, yeah.
which is
And then together, those make 1 over sine.
which is cosecant.
So we have,
Secant, theta.
I've lost
Say
letters.
so.
I don't know.
Secant theta.
Sec.
Yeah, that. There. In, yes.
Can you do number 11 next?
Yeah, so it was 9, 10, 11, then 12.
This is no fair.
Are we feeling good?
Me and
Mhm.
Samantha are the oldest.
I think
There's only
Right.
2 of us. And everybody's like, you didn't even get past chapter 8. So when we were taking that diagnostic test, everyone was like, what's this? And me and Samantha were like, and then we got to the machine. They didn't do biology. So when we were getting to like the basic development and all that,
Okay, which one's uglier?
Right side.
The right side's ugly.
I did the.
We're more accustomed to tangents than cotangents.
They're right. They're both ugly. Now, typically I tell you to figure out your ugly side. They're both ugly. And then I say, the next thing I usually say is work it in terms of sines and cosines. Yeah? But look at the answer over here. If I was to work with this, and I'm looking for that word, couldn't I use this as 1 over tan
yeah.
instead of doing that sine cosine thing?
Yeah.
Yes.
Can you also work with the other side and do 1 over cotan?
Mhm.
And I did that, but I didn't get to the right answer.
You didn't get there. Okay, so which one do you want me to do?
Whichever do you think is the best one to
Do
do?
the white one. Make it tan because it looks nice.
Okay.
Yeah.
Yeah, you're right, 10 does look nicer.
It does.
It's like cotton.
Is that good?
Mm-hmm.
Does that make sense to everybody? Or not? Okay, now I would get a common denominator on the top and a common denominator on the bottom. So over here, I would multiply this by tan, right? It'd be tan minus 1 over tan. Does that make sense?
It's just kind of confusing where you have all those fractions.
Yeah,
On each
so
other.
really I'm taking this and multiplying it by tan over tan is what's happening in slow motion.
Mm-hmm.
Okay.
So that way that 1 over 1 is now,
Tan
can
over
be
tan.
subtracted with the tangent.
Right. Same thing here. This would be tan plus 1 over tan. And what do we know about denominator? Two fractions that have the same denominator divided,
Ignore denominator. And we have the answer.
and then we have our answer.
That was a lot simpler than I thought it would be.
Yeah, it really is when you do that. You could go to sines and cosines and then go back to tangents, but that'd
It'd be more
an
work.
extra step. Mhm. All right, 12 I think was the last one. Right.
And then we can just finish this together. Or
Yeah, I'm gonna give you another worksheet, but yes, you can finish this like together. How's that sound? So 12, 1 minus tan squared over 1 plus tan squared equals 1 minus 2 sine squared. Okay, I've got x's and thetas everywhere. There. What do you think?
left.
Left.
I agree.
We don't, yeah.
What are my Pythagorean identities?
Oh, this is. Where is it?
Is it 1 plus 10
What's it,
squared
12?
equals something?
Yeah.
Stick to the left.
1
Okay.
plus tan squared equals secant.
Okay, so this is actually equal to secant squared.
Yes.
What do you think?
Yeah.
You can. I mean,
Yeah.
One?
a way that
That's what
works,
I
but
did.
there's probably another way that works.
Okay, let's see. So we have 1 minus tan squared, no theta. It wants to become a theta. Over what, you said secant?
Secant.
Okay, that's cool. Okay, so we picked the left side. We actually did this, we didn't go in terms of sines and cosines, but ultimately we should. Why?
Because the answer is
The
inside.
answer has sign
Yeah.
in it, right. So that's what I would do.
Secant. Cosine.
Yeah, 1 over cosine.
Reciprocal of cosine. So
Yeah,
you
1
can
over
flip that up.
Mm-hmm.
and make it
And do your thing.
And then
times all
cosine over
times all
1
that.
times sine cosine, and the cosines cancel out.
So it's cosine.
Okay, so the first thing I did was took the tan and rewrote it as sine squared over cosine squared. Does that make sense? Okay. And then it's over 1 over cosine squared. Okay, is that good for everybody?
Mm-hmm.
Is that cool? So then I'm going to take that denominator, I'm going to flip it up and multiply it through. Does that make sense? Yes.
Can you do the thing where you did with the, we make that 1 able to subtract with the sine squared?
We could do that. So what would you do?
You would multiply, you have 1 over 1, you multiply the denominator by cosine squared, and then the top by cosine squared.
Okay, so you're saying you want me to do the cosine squared over cosine squared thing, so I have cosine squared minus sine squared over cosine squared?
Yeah.
Okay. Does that make sense to everybody?
Yeah.
So over here I would have cosine squared minus sine squared all over cosine squared all over 1 over cosine squared. Okay, old lady trick.
Flip
Mhm.
it,
Before I flipped it, what could I do?
the denominator.
Get rid of the denominators, right? 2 fractions, same denominator, ignore it. Actually, I can ignore everything from here down.
Yeah.
So what I'm left with is cosine squared minus sine squared. That's as far as you got. My final answer is in terms of what only?
Sine.
Okay, can this word right here be
I
converted?
got it.
It can, right? What is it?
1 minus sine squared.
1 minus sine squared. It doesn't hurt to look back at what the answer is to see what direction they want me to go in. Okay? So, final results, 1 minus 2 sine squared.
Mm-hmm.
What do you think?
Pretty good.
Not bad. Okay, so on Monday when we started working the bit of review, we learned how to solve for the x's and the y's, right? On Tuesday, yesterday, we started working on verifying and getting trig identities back and forth. And then we used a little bit of the actual Pythagorean identity and those things. How do you put it all together? Well, I'm going to hand this out. Maybe.